Yes, let us understand the term class. I said previously, as like in a college, different classes remain. Likewise, our point groups are equivalent to college. If we consider a building, then classrooms are separated by means of walls. So that wall is physically notable, understandable. What kinds of walls do remain present in group so that classes we can establish? Yes, it needs some kind of the mathematical treatment, mathematical understanding. And within a class, there remain one kind of relationship. Or in two different classes, that relationship doesn't remain. I want to consider those operations in a group which are related to each other by means of conjugation. Means I want to say the members present in the class, operations present in the class, they are conjugated to one another, conjugated to each other. Conjugate to each other means they are similarity transform of each other. And similarity transform of each other means they are simply mathematically related to each other. And that mathematical expression is x inverse a x is equal to b, means b is a similarity transform of a through or via x. This is a mathematical expression to find similarity transformation or similarity transforms or conjugacy or conjugate operations. If we could find B is a similarity transform of A, means B is a conjugate to A, means those belong to same class. With the help of this mathematical relationship, we can establish a complete compartment, complete room, that's a class. So boundaries of the class by means of walls we can understand. Now boundaries are established here by means of this relationship, by this conjugacy, by this similarity transformation. It's a beauty of mathematics. Interestingly, the members which are not in the class, they do not follow this similarity transformation. Now you may be with some doubt or question, what exactly the similarity transformation, how can it establish a class? I give you one example. Now I am standing at this position. It is zero position, consider. And I can move from this place to my right side or left side, or I can move front or I can go back. Suppose towards you, from my point of view, is a north direction. So it is east, west, and behind me south. And between east and north, east to north, I will say. Let me consider A. The operation means moving one step in east to north direction. And let me consider X. The action is moving one step left, means to the west direction. I repeat, A means moving one step in east to north direction, and X means moving one step in west direction. Then what is X inverse? What is inverse? Inverse is a reciprocal, means it get cancels, so that multiplication of those will give result of identity. X inverse into X is equal to identity. If I consider X as a one step left, then what will be the X inverse? X inverse will be one step right, one step towards east direction. Let me do the action now. It is my zero position. X inverse means one step right. A means moving in east and north direction. I am going in east and north direction, one step. Now X means one step left, one step towards right. Which one? West. Yes, one step. What happened? Previously I was to that position. Now I come to this position. What is A? A means moving in east and north direction. So I should be there. But because of X, because of moving to west direction. Now I came to this position. This A position, suppose if only A would have been there, is this position, A position. And this resultant position because of x inverse AX, because of similarity transformation, those are conjugate to each other. They are neighbors of each other. They are friends of each other. They belong to same class. Likewise, students, we established the boundaries. Those are the mathematical boundaries. Now question will be that how boundaries are there? Suppose if I continue such steps, one time will come where I can't move out of this wall because restrictions are there, no? Likewise, mathematically those things are restricted and we can get a class. And in that class, friends remain. In that class, various operations remain. In that class, various neighbors remain. Class also has an order. Number of members present in the class, number of possible operations in the class is called as order of the class. And this order of the class, say G, is integral divisor of order of the main group, that is H. Means H upon G is integer. Are you understanding similarity transformation? Let us revise. What is similarity transformation formula? X inverse AX is equal to B means B is a similarity transform of A through or via X means A and B are conjugate to one another. A and B belong to one class. Let us know more about the conjugation. Self-conjugation I want to talk. Means operation A can be conjugate to operation A. Means we can find any such x in such a way x inverse A into x is equal to A. Means A and A are conjugate to one another and every operation remains conjugate to self. Everyone is neighbor to self. It's other way, mathematical point of view. A alone can be the member of the class. Second concept of the conjugation I tell to you. Mutual conjugation. Means x inverse A x is equal to B. It means A and B are conjugate to each other. B is a similarity transform of A through X. Similarly, we can find any other operation y inverse B y is equal to A. Means A is a similarity transform of B via y. Means A and B are conjugate. Previously I said B and A are conjugate. Means A and B are mutually conjugate. Means A and B if are neighbors. If B is a neighbor of A, then A will be the neighbor of B. That's a simple way. Mutual conjugacy means any one derivation if we could able to find A and B are conjugate to one another, it means those belong to the class. Not necessarily we should prove that A is a similar transform of B. So what we did? First conjugation aspect, self-conjugacy. Second, mutual conjugacy. Now third aspect of the conjugacy, that's associative conjugation. Means if x inverse AX is equal to B, means B is a similar transform of A, means A and B are conjugate to each other. And if we find y inverse AY is equal to C, means C is a similar transform of A and C are conjugate to one another. Previously what was the statement? A and B are conjugate. What is the statement now? A and C are conjugate. If it is a case, then so we can get the mathematical statement P inverse BP is equal to C, means C is a similarity transform of B, means B and C are conjugate to one another. First statement was A and B are conjugate. Second statement was A and C are conjugate. Now third statement B and C are conjugate. It means A, B, C all are conjugate. A, B, C all are neighbors. A, B, C all belong to same class. It is a third aspect of conjugacy. So now if I come across to the concept of class, then complete set of the operations which are conjugate to one another is termed as class. Means what was our first statement? The elements which are conjugate to one another, they constitute a class. Now see the second statement. All similarity transformations constitute a class. What is similarity transformation? X inverse AX is equal to B. Third important point in considering concept of class. Order of a class, let's say G, is an integral factor of order of the main group H. Means H upon G is equal to integer. Let us describe this term by example. Say C2V is a point group. In C2V point group, what is the order? H is equal to 4. And which are the classes present in that C2V point group? 4 classes are there. Whichever operations are there, identity, C2, sigma xz, sigma yz, all do belong to separate classes. Means in a class only one student, or consider only one operation. What is the order of each class? G is equal to 1. Here all 4 classes for C2V point group are mentioned. If I have to find classes in C3V point group where H is equal to 6. H means order of that point group is 6. So classes can be with order, can be 1, can be with 2, or can be with the order 3. Let us see which classes are present in the C3V point group. 3 classes are present. First class where E is the only operation, order is 1. Second class where order of that class is 2 and 2 C3 operations are there. Which are those 2 C3 operations? C3 1 and C3 2. And third class, third is a number here, where order is 3. G is equal to 3. Which are the operations? 3 sigma V, 3 vertical planes are there. How we label them? Sigma, sigma dash, sigma double dash. All those 3 operations constitute one class. Means all those 3 operations are neighbors to each other. All those 2 rotation operations are neighbors to each other, and identity alone remains. No other operation is there as a neighbor, as a part of the class. So this is a division of the college. This is a division of the point group. To make the concept clear, I took these 2 examples. One was C2V, where 4 classes were there, and other is C3V, where 3 classes are there. In C2V, H was also 4, classes also were 4. In C3V, H was 6, and number of classes were 3. Let us see further details of the classes. In abelian point group, each operation is a class. Example was there, no? C2V point group. What is abelian? The concept will be clear very soon. But time being, remember, in an abelian group, each operation itself remains a class. And in a non-abelian point group, number of classes will be certainly less than the number of total operations. What is example? C3V, where H is equal to 6 and number of classes were only 3. And it is important. One operation can belong to only one class. It is not allowed student can sit in the FIBC class as well as the SIBSC. So one operation belongs to only one class. Identity operation is alone where only one member remain present in the class. Identity is such a class. Identity itself is a class. Identity, in the class of identity, only one identity remain present. Only one student in the class. What is the order of that class? 1. As like identity, I means center of inversion or inversion operation, also remains alone. It has no other friend. It itself has a friend. Self-conjugacy. So here also, order of that class is 1. Means identity was there, center of inversion, and one more will come. I'll tell you. If you consider any axis, say CN axis, then on that CN axis, which are the operations are possible, then all operations do come in the one class. For example, C3 was axis. In that C31, C32, these 2 operations were there. Both were belonging to one class. Okay, means here the coinciding axis if remain, then separately we represent. But without that, other operations whichever are possible, that generally I am representing. Here particularly, specifically I am not defining. So time being, remember, the axial operations come in the same class. In addition to the principal axis, there remain a subsidiary axis, subsidiary C2 axis. So similar kind of C2s belong to the same class. In point group, vertical, diagonal, these planes are possible. About horizontal, I am coming next. All vertical planes in the point group constitute one class. All diagonal plane constitute one class. In case of C3 point group, 3 vertical planes are there, and all those 3 vertical planes belong to same class. Therefore, we represented 3 sigma V. Yes, now is the time of horizontal plane, and horizontal plane itself is a class. Means identity alone was a class, center of inversion alone was a class. Likewise, horizontal plane separately remains as a class. And that is the reason Why? For in priority, we were giving horizontal plane at the beginning. If it is existing, then we are giving priority to the improper axis of rotation. Yes, if you go to the BCl3 molecule, you will find horizontal plane separately we are representing. Vertical planes all we are representing. Now let us sum up. Class is a collection of the elements which are what? Conjugate to one another. And conjugacy decided by means of which mathematical operation? Similarity transformation. How can we define similarity transformation mathematically? X inverse A, X is equal to, means B is a similarity transform A through or via X, means A and B are conjugate to one another. And third point, the order of the class, that's a G, is an integral divisor of the order of the main group, that is H. Then self-conjugacy, mutual conjugacy and associative conjugacy. Various examples we have discussed. And which operations remain alone in the class, that also discussed. Which are alone? Identity, center of inversion and horizontal plane. Is the concept of the class clear? As a homework, I am asking very simple questions. You have to find out the number of classes. Already I told to you, mention number of classes present in C2V point group and second C3V point group. Just answer the number. I am waiting for your answers. You promise me that you will complete the assignments. Let us apply this concept of classes to one point group, that's a C2V point group. Only just we come to know 4 classes are there, but we have to derive that, we have to prove that. That we will see in next part.